Hey, this is Steven from LegitTechTutorials, and welcome back to our product design series. So we're back working on the industrial grade mini shredder. So I know it's been a while, basically since last time that I've been on. Today is the December 20th, 2016. I started the Kickstarter about 15 days ago, and we are up to $1,900 for my minimum of $2,300. So what I'm trying to do right now is I'm trying to decrease price, start to send out quotes to try to get quotes from other places for laser cutting, and also I want to do a metal. So I did a plastic version, I did an acrylic laser cut version, and so of course there's been a few things that obviously happened since last time I shot, but I did this last time I did any of this, which, of course, like I said, I didn't want to do that. I wanted to do it all in the video, but I was running out of time to get the Kickstarter, so I decided to do it do it ASAP. Alright, so I went in and I designed and I did a inventor layout, not inventor, Adobe Illustrator layout for laser cut out of 1/4" acrylic to laser cut a smaller piece. This is actually this is what the model that I used for the Kickstarter, and this is actually a 65% scale model. So I took the scale down design. I took the scale model and I scaled it down to 65%. And then of course me, trying to get it out really quick to get the Kickstarter out, I didn't calculate that even though I changed this 65% as far as the square, it doesn't change the thickness of the material. The thickness of the material is still 1/4". So I didn't have these progressively rotated blades weren't all the way progressively rotated. You can't really tell from this picture, so I guess that's our little secret, that this is actually not, these are not, so the next blade would have been right here, but it wasn't exactly perfect. So here is another view of that, and it came out really nice. And these are custom 3D printed shafts. Reason being is because this originally is square is originally 3/4", right? But if you scale it to 65% of the size, this is like 0.55, right? So you're not going to be able to find, a square piece of acrylic like that, which is 0.55. You have to be custom cast or custom extruded, so I just 3D printed these custom 0.55 shafts, and these go all the way down. And then the one thing that I didn't predict, well, I knew that was going to happen, but I didn't know it was going to be as bad as it was the tapering of the square shafts on the laser cut parts. So this piece right here had a lot of, so all these pieces, even these pieces, but the only thing that I was mainly worried about was anything with the square shaft piece. All those pieces had a crazy taper. So any sort of laser water jet or plasma, they all taper the cut so that when you look at like this here, this is tapered. So if you look straight on, let me look at the straight on picture. So this is like tape. You can see that it's slightly tapered. I didn't sand these, so these are slightly tapered. So what happens is that one side of this hole is short measurement or exact measurement, and the other side is high because it has a slight angle. A slight angle of taper from the top to the bottom. And that taper depends on the speed that you go, well, for laser, the speed that you go through, the power of the laser, and the material, and the thickness of the material. Right? So that was there. So basically what the biggest issue was, I had to go in and hand file all these holes, every single one of these. So you can imagine if this was actually the full-size shredder and had 24 shredder dials instead of the 16 shredder dials, I'd have to go in and hand file all 24 of those and make sure that they fit on the shaft. And then also as you're filing it, you don't file it perfect. You get some play back and forth. So some of these were slightly tapered. Also, another thing is I had to do it on all these shredder dials and all the spacers that are in between, which again, there's another 16 spacers on this model and then 24 on the full size. So you had to go in and shave every single one of those things down so that it was going to work properly. So hopefully when I do this test piece out of steel, I will be able to do it without having to go in and hand file. So that being said, yeah, so this is just glued together here, right? Yep. Yeah, that's pretty much it. So, and this guy, I finally got to, originally I thought it didn't work, but it actually does work. It kind of binds up here when you have these two attached. But what happened is on one of these corners, I can't remember which corner it was, the glue actually built up and created a fillet in this corner. So what would happen is as this tooth came around, it would hit the fillet and get stuck. I eventually fixed it. I went in with a file and filed out that glue. And then now I was able to turn it with a crescent wrench, because of course you're not going to be able to find, at Tech Shop I couldn't find a socket for these guys. That fit exactly, because it was a little big, right? Yeah, so with a crescent wrench, you could turn it and you could actually shred paper. So that was pretty cool. So I finally got to shred something, and then from that I found a few flaws. And we're going to go into finish laying out the full model, because I accidentally forgot a few things inside this other model. Inside the other Adobe Illustrator, make sure I had a few things that I miscounted. I miscounted how many cutter dials I had. I had 16 instead of 24. What else? Oh yeah, we're gonna fix one thing, and that thing is, remember how when I originally designed it, these were in line, so all these dials were in line. So I had a bit of an issue with this guy binding. The main issue with it binding was what was happening was that as this guy was coming around, the tooth, because one dial isn't nested in between the gap of the other two dials, what was happening is as this tooth came around, it sometimes would get stuck on the lip. So what I'm saying is, if they weren't perfectly spaced, it wouldn't come around and go right into that hole, right? And so one of the other things that you could think of is like, okay, well, what if you used a bigger plate for the spacers, which would technically work, but you want to have as little space between the two cutters as possible, because then that maximizes your shear. The closer the cutters are, the more transaxle, I think it's longitudinal, so longitudinal, and then, yeah, it's transaxle, it's trans something, which basically means opposite loads, opposite forces on each side, which causes shear. So you want these guys to be as close as possible. The farther the gap, the more forces, the more unnecessary forces you're putting on here, and the more weird stuff you're doing to your plastic. And the more chance, instead of shredding your plastic, it'll actually get stuck between the two gaps, between the gap of this tooth and the gap of that tooth, and also the gap of this dial. So you don't want to get anything there, so that no plastic gets stuck in there, in that gap. Because if it shreds and it's not close enough, there's a little bit of play, and it's like paper thin, like a piece of water bottle, it'll get stuck right in between those two blades, and then basically jam your machine. Alright, other than that, everything fit. Like, it fit together perfectly, glued together very easily and stuff, and all these things were perfect, came together perfect. Of course, like I said, the main issue are these square cutouts, having that laser taper, and then having to file that laser taper out. And you can imagine way different filing plastic than it is filing metal. It would take a lot longer, maybe double the time. And of course, you have, way more dials. Alright, that being said, what I did is I created this Adobe Illustrator file, and then I went over to Tab Plastics downtown, and then got some leftover acrylic that the guys had down there, and was able to cut one out. I got some $2 acrylic, and then was able to cut out a 65% scale model out of the $2 of acrylic. So let's go ahead and space these guys out a little more. And then this is a whole nother thing about maybe finding some optimization software. And again, I'll show you how I got these images of the parts, which was kind of difficult on Fusion, so I want to get into that also. And again, this might cause some issues as well, because we definitely need some space to have automatic tabs added onto here for the laser, but I'm not too worried about that for right now. So we're going to have to increase the size of this dock, because I'm going to need to, and again, this dock is for a this layout, which would be in either PDF or DXF, will be for sending to laser cutting places or water cutting places to get an estimate, see if they can do it better than I can at Tech Shop. Or cheaper, better and so obviously if it's cheaper, I'll just have them do it, because then I don't have to do it, and also it's cheaper, so that's a great deal. So I'm going to send this out and see if they have cheaper ways so I could pass these savings on to drop the price of the machine to to the buyers. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 dials. I'm supposed to have 24. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25, whatever, that's fine. Okay, so let's go into document settings, edit our boards, and stretch this guy a little higher. And then also this will tell me how big of a sheet I need. Oh, also I need to make sure that I'm grabbing the right ones. So for these, they're slightly twisted. Four. I'm missing one more set. 4. Yeah, I'm missing the rest. I need okay, so this is a good example of how I'll show you guys how I did it. Okay, so what you have to do is in Fusion, it does not let you. So yeah, I'm missing the 60 and the 75. So it does not let you. I didn't copy those right. Okay, it does not let you. So if you're going to take a DXF, which is what these are, you want these in DXFs, right? What you do is it only lets you take an image of a sketch. So if you go here and you try to like right click or try to right click, like you can't do anything. Make doesn't do anything. You know, none of that does anything. So what you could do is you could right click, and there you could save a sketch as a DXF. So what I did was I just took a sketch of the top. What I did is I just hit create sketch, clicked on the top, and then projected the entire shape onto that sketch, and then saved that as a DXF. So for example, this guy would be, you know, this guy would be just the sketch for the DXF. So let me show you how to do that on this one. So this one, you just hit create sketch, on that face, project, oops, project, and just project that entire face. And stop sketch. Now, and then these guys you want to be also in inches because the other one is in, because my Adobe Illustrator is in inches. So I'm going to turn that into inches. And then I'm going to save as DXF. And then I'm going to go into my Dropbox. And then this is going to be, this is the 60. It's pretty simple. It took me a while to figure that out, so I'm helping you guys with that. Okay. Open this guy, do the same thing. This is the 75. Create sketch. Boom. Project include, project the entire thing. Stop sketch. Change from millimeters to inches. Go into sketch. Save as DXF. And then from this you could use it in any sort of like layout, 2D layout software, like that type of stuff. Or also the water jet, the flow jet from Flowjet Mach 2 that I'm going to work on at Tech Shop also takes in DXFs only. So I'm going to export the AI as DXF, and most companies that do water jet and stuff, water jet and laser, they're going to accept in DXF as well. DXF and PDF, because you can go from PDF to DXF. Sketch 2, sketch. Okay, this is so yeah, DXF, ready to go. File, place. I'm looking for 0, 15, 30, 45, and then 60 and 70, right? 60. And there she is. So a little bit high, so I could drop. And of course, I really like this for its layout. It's a very, very efficient layout tool because you have all the alignments, so you could have. But I would still like to have something. So that's 4. That's good. So now I need the final few. And of course, again, like I said, I still need to go in and optimize all the shapes for these guys. So here's another one. Oops. 2. 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 8, 16, 24. Boom. Ready to go, and we should have all of these. I call them again. Column half moves 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yep. So again, what was this document size? Document size is about square, 24 by 25. So let me see, can I cut off? Yeah, what's the actual size? Oops. So yeah, it's about a 24 by 24 piece. You know, because we could do some finagling here, get that shoved in. So I'm gonna find some software that'll automatically lay this out most efficient, and then give it a certain gap between all this. But you know, this is what we got. This is a full piece here, so it takes a 24 by 24 inch piece, which is a 2 foot by 2 foot piece, to do one full shredder. So what we'll do is, I see we got another 10 minutes. So all we're gonna do for that other piece is hopefully we could get away with taking this in just a little bit, which I think I actually did already, if I'm not mistaken. I might have done that already. Let me check. Which is on this guy. I'm not even sure how to use even the version control on this thing. Okay. So it says go in here. Oh. 1124. I'm not sure if that. So I'm opening on web. Let's see what I did. Oh, the wrong button. Should I get lost? Okay. Try this again. So he changed the layout. Oh, here we go. Okay, well, it's hard to measure in this, unfortunately. 0. And then this is 1.5. What? Sorry. 3.5. Derp. Okay, so I have clearly already done this, but it's quite a bit. So what is this length then? How much did I change it? Half an inch? No. Okay. About 0.25 inch. Nope, so I did about 0.3 inch, so that's 1.5 each side. So basically what that means is I went from I remember now I did like 1.3. 0.3, right? So I moved it over. I think that's probably. I think that's a little much. Because these are not resized. It should be 6 inches. Yeah, so everything's still resized correctly. Let's think about this a little more with my calipers here. .3 of an inch is quite a bit, because one's going to move forward and the other one's also going to move forward. So it's like that's like a total of. It says 0.3, so I must have only moved it 1/5. This is a total of 0.3 to one side, so it means I moved one out 0.5 and the other one out 0.5 to get that total distance. I mean, to me that looks good. So what I'm going to have to do is I'm going to have to check that from my other one here. Because that's 1.75 pretty much. Plus 1.75 plus the 0.15 plus the other 0.5, so it's 2 inches. So now this is a total of 2 inches from one side to another. I'm gonna have to look. Let's do this guy. Let's get just. Let's re-update these, because now they're gonna have the things on top that I can mess around with. Alright, cool. Okay, so what is that? Distance 0.3. That's not good. So, yeah, this is going to move over 0.15, and this other one's going to move over 0.15. That means that those spacers are going to have to be stupid small. 0.15 and 0.3. So yeah, the max. So even if I had like this barely hanging on there, so that's probably what I'm gonna do. Is it's probably gonna be like a minimalist flange bearing to where it had the minimalist spacer, so it like barely grabs on there, minimal material. Because right now we have some decent meat on there. Like there's a lot of meat, so we'll probably have it just like come close. That being said, because this is the worst case scenario when it's pointed like that, right? because now it has the farthest distance there. Okay. So that's a total of 0.82, right? Yeah. It's way too big. Okay, well that is something that we're definitely going to need to check into further to get those closer together. And also, I don't want them to be too close, because if I get them, the more closer I get, the more space I lose as far as how much shredding distance I'm going to get max. Because right now it's kind of maxed out. So I'm going to have to, do something about this guy. I wonder if I could leave some notes or something somewhere. Okay. There you go. Alright, so that's going to be pretty much it for this video. This has been Steven from LegitTechTutorials. Thank you guys for watching, and I'll get these out to some companies. And also, another big thing that I need to do with this is I need to get this out to, I need to get this over to TechShop and then run it through the software so I could finally figure out what my inches per minute is going to be and what my final cost is to cut this out, so I could really have the perfect cost. Because right now what I did is I'm using this system called Swiftcalcs, which you guys should check out. It's relatively new. I think it's been out for a month now. And basically what it is it's like a sorry about that. It's like a software for doing spreadsheets, but instead it's set up as a worksheet format. So it's like writing out problems, engineering problems or math problems or chemistry problems, something like that. And then it goes through and does all the calculations for you. So it's kind of like programming, but without doing any code. And it's mainly for materials engineers. That's what it seems like it's designed for. And also another thing is that it has a plug-in for Fusion, so you could actually drive from calculations in Swiftcalcs. You could drive dimensions in Fusion. So you say, okay, x, this is x value. This gap is x value. So for example, if I wanted to calculate this in Swiftcalcs, I'll have this as x distance. And then Swiftcalcs, I'll have it calculate the length of the dial and all that stuff, and then have it sync with Fusion, and when you sync it, it'll go into Fusion and change that variable for you. Another thing you could have in Swiftcalcs is a whole bunch of sliders and stuff like that. So like I said, so sliders that are attached to variables. It's pretty much like doing calculations by writing a program to do the calculations, but without writing a single line of code. Which of course I'm a programmer myself, but still it's a lot faster, And also it's web based, so I could go on my phone and do it on my phone, and I log in through Google and go through it on my laptop, and it calculates it. You change a variable and it articulates the calculation all the way through. So right now, I'm not using it for any I'm not really using it for any material science purposes or any sort of calculations like that. I'm using it mainly for actual arithmetic calculations of profit margins, costs, steel costs, area costs, cutting time, cost of cutting, all that stuff for the Kickstarter. And also another great thing it has is it has a giant material library that gives you all the tensile strengths, densities, and stuff of all different grades of materials, which I've used quite a bit to evaluate materials and material costs. So I would right now I have the variable that generates what I'm going to charge for the shredder is generating from a variable with a slider where I give it a random inches per minute of the water jet, because the water jet's pretty expensive, as it costs at TechShock costs $3 a minute. So if I could figure out exactly how many inches per minute I could cut without having a crazy like that pitch issue on that pitch issue with the laser, then I'm golden. So, but you can't just go online onto a calculator and figure it out. You have to actually have the file and then go over the software, and also the software's not free, so you can't just download it. It costs quite a bit of money supposedly. So for the FlowJet, so you have to go into TechShop or wherever you're gonna go. Give it the file, tell it the material, have it auto path, and then go to the actual machine, go to the actual water jet. Hopefully nobody's on it. You go to the actual water jet, plug it in USB, and then have it calculate the time the time and the cost it's gonna take. Then you know exactly the cost. But I can have it calculate the cost from the inches per minute. So get a pretty rough. So just going to the software on the desktops, not necessarily on the water jet, the computer that drives the water jet. I could go on there and have it tell me the inches per minute. Go into Swiftcalcs, tell Swiftcalcs the inches per minute, and then it'll calculate me my margins according to my selling costs, and also material costs, cutting time, and final costs. Alright, so that's pretty much it for this video, and I'll show you guys the Swiftcalcs eventually when I have a project for it. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like in this series and other series as well. And I'll catch you guys next video. Thanks for watching. Take it easy. Peace.